Hi there, thank you for joining me. What we're going to do for this lesson is discuss the differentiation of the exponential curve y is equal to ex. Okay, so we're going to be discussing the differentiation of y is equal to ex. Now, this particular function is a special function. It's the only function where its differentiation is the same. The differential function is the same as the original function. So when you do a differentiation, it looks exactly the same. What that really means is that the graph, so let's say this is your y is equal to e to the power of x graph, right? If this is your y is equal to e to the power of x graph, if I were to draw another graph, its differential function, it will look exactly the same. So the differential function will look identical, and this would be y dash, right? So in this case, that's what this means. It's the only function where this occurs, and this is the main thing that you should remember when we're doing differentiation. This leads to a few results. So let's say I want to differentiate something like, let's say let's an example. Let's say I want to differentiate 5ex. If I want to differentiate this, how can I do it? What I can do is rewrite this. So what I want to do is I want to differentiate 5ex. So I'll rewrite this as differentiation of, and I'll put the 5 because it's just a multiple. This 5 here is a multiple. I just take it outside. And so therefore, the purple part here, it's exactly the same. And we know from the formula here, or from the differentiation here, that this part we understand to be ex. So we just put the 5 in front of it times this purple part, which is ex, and so the result is the same. Okay, and if we take away the 5 and we just use any number, so let's say take a as a number, so a ex. If I differentiate that, I can do the same thing here. This is the same as a differentiation of ex, as long as a is a constant. And so what we get is we get a ex, right? So in short, this the first formula, the fundamental formula for differentiation e to the power of x, allows us to do differentiation of any constant multiplier. So the differentiation of k e to the power of x is equal to k e to the power of x. All right, so this is the original formula you should know. It leads to the second formula, this one here. Now this particular formula, it's important to note that it allows us to do a few things that may not be readily seen. So for example, you just need to be careful to see the coefficient in front of the ex. You need to be careful to see the k part, right? Here's an example. Let's say you've got a question where you need to differentiate ex over 3. Well, you should understand that the k part is the number 1 over 3. 1 over 3 is the k. So you can take the 1 over 3 out, right? And so therefore, you can differentiate the rest. and this will give you 1 over 3 EX. Just be mindful of that fact that if there are fractions or something in front of the number EX, it may not look as obvious as you originally see like a number. If it's a fraction, it may hide itself a little bit. Other than that, it's very straightforward. There's no problem in doing that. The other thing I should say is that it also leads us to a further result, which is, let's say I want to differentiate a different thing. Now this will be a bit harder. So let's say I want to differentiate something like e to the power of 2x. Now our problem is that we know how to differentiate e to the power of x, right? So if we look up here, e to the power of x, we know how to do it. But if it's e to the power of 2x, even though it's just a small change, there's only a 2 in front of the x, it's still different, and we can't differentiate 2x. Right? The differentiation of a function of 2x is not e to the power of 2x. It's not exactly the same. So we need to do this differently. And how we can do it is this way. The differentiation of e to the power of some function, in this case it's 2x, f of x, is equal to f dash x times e f of x. Okay, so in other words, let me rewrite that. If I want to differentiate e f of x, this is equal to f dash x times e f of x. So remember that this part stays exactly the same, and we just multiply it by the differentiation of the power function. Okay, so here's an example. Let's say I'm differentiating e to the power of 2x. So what is being highlighted is this 2x. I just need the differentiation of this 2x. The differentiation of 2x is just 2, right? Remember, the differentiation of 2x is just equal to 2. So if we think about that, we put the 2 in front. Now the rest of it should be exactly the same. Multiply by e2x, right? So the formula here, if you're differentiating something that is not just x, e to the power of x, but e to the power of something else, then the formula for it is that you take the differentiation of the power and you multiply it by the original function. Let's do another one, just so that you can get the hang of it. So let's say this is our first. Let's do a second one. So let's differentiate e to the power of minus x. Now you might think that there's no coefficient, but there is. It's a minus 1 here. Right? There's a minus 1 here. And so when you differentiate that, that will become minus 1 times e to the power of minus x. Remember the second part here, this part here stays exactly the same. And so your answer would be minus e to the power of minus x. That's your answer. Okay, we're going to do one more example, just a little harder, to get us away from simple coefficients. So let's say we differentiate something like e to the power of square root of x. This is a little harder. So firstly, we should understand that the differentiation of the square root of x, if you recall, is equal to 1 over 2 root x. Right? Just understand that part. If you do it yourself, you'll find that that's the case. So what happens now is that we can take this differentiation, put it at the front. So 1 over 2 root x and then everything else stays exactly the same, times e to the power of square root of x. So your answer is e to the square root of x over 2 root x. And that's your answer there. Okay, so that's a differentiation of the exponential function e. And you can use this to find gradients and tangents and normals, which we'll discuss the next time. Thanks for listening.